Hello, today I will show you how to use Python to solve differential equations. Differential equations are basically equations with derivatives. They are commonly used for the description of various processes. Here you have few examples in different areas of engineering. First example is the growth of microorganisms. Second one is heat transfer, and the third one is spring motion. You can find many other examples in almost any field. Here we have the classification of differential equations. We can divide them with respect to the order. It can be equal 1, 2 or higher, generally n. We can divide them into nonlinear ones and linear ones, and also into ordinary and partial differential equations. The classification is important as different type requires different approach. Especially you will solve partial differential equation using different method than ordinary one. In ordinary differential equation, you have the derivative with respect to only one variable, like here with respect to t. In opposite, in partial differential equation, there are derivatives with respect to more than one variable, like in this example, where we have derivatives with respect to x, y, and z. Let's go to practice. We will consider this differential equation. It is an ordinary differential equation as there is only derivative with respect to t, and this is a first order differential equation as the first derivative is the highest one. We know that at time equals 0, this is the value in brackets, y is also 0. It is an initial condition and it is necessary to get the solution of this differential equation. First, we will import necessary libraries. The main library in Python for solving differential equations is SciPy. We will use ODE-int from SciPy integrate. Next library we will use is NumPy, and the last one is matplotlib to plot the results. The main idea in solving differential equations with SciPy is to create a function which calculates the right-hand side of the differential equation. It takes two parameters, y and t, the ones which are present in the derivative, and it returns the right-hand side of the equation. You need to remember that it is necessary to use the equation in the presented form, that is dy dt equals the rest. So the function returns the expression at the right-hand side, in this case minus y by t plus 13. Next, we define the initial condition, that is the value of y in the initial moment, in our case y equals 0. After that, we create an array of time values. The time starts in the moment specified in the initial condition, that is 0, and it ends in the moment we are interested in. It is not specified by the equation directly, you know it from the process you simulate. Here we arbitrarily say that we will find the solution from 0 to 5. Very useful for that is linspace function from NumPy library. Linspace creates an array of evenly distributed values. Here we say that we want an array from 0 to 5 with 10 elements. Now we will obtain the solution of the differential equation. We use ODE-int for that. The function accepts three parameters. The function, which calculates the right-hand side, we called it returns dy dt, the initial condition y0, and array representing time values. The result we get is y result. If we take a look on it, we will see that it is an array and it has 10 elements. Each element in this array corresponds to time value in the array. So the first value is y at time equals 0, the second one is y for time equal 0.55, and so on. Finally, we will make a simple plot. We use plot function with two parameters, t, which is time, and y result, which stores the solution. We set x label and y label to describe the axis and show the plot. The curve represents the solution of the differential equation. It is the function y of t. We see that the curve is not smooth. It's because we used only 10 points for the solution. It can be easily changed by using the value of, for example, 100 in a linspace for generating the time vector. It is done below. Here the plot for time vector with 100 elements. We see that the curve is perfectly smooth. Thank you and see you next time.